Welcome to E-Pathashala. So, this will be a series of lectures on computer networks. So, what we have been looking at in the previous lecture was basically on the HTTP protocol. So, we are looking at application layer and we are looking at different protocols that are there at the application layer. So, we looked at the HTTP protocol. So, in this talk what we will do is we will take a look at some additional features that are used in HTTP in order to support things like cookies and caching, and then we will also take a look at the basic protocol used for email, which is SMTP. Do a quick overview of HTTP protocol. There are two things that we need to remember. It is basically a request response kind of a protocol. Request messages go from the client to the server, responses come from the server back to the client, and it is a stateless protocol. So, each request is treated independently irrespective of what request had come prior to that. Now, because it is a stateless protocol, it is very difficult for certain websites to maintain information about the users and accordingly provide very efficient service. So, in order to provide some kind of mechanism by which state can be maintained, a mechanism called cookies is employed, and HTTP protocol has certain additional header lines which are used to support this idea of cookies. So, what exactly is this cookie? It is a small file which is maintained on the client side. So, most of the major websites today they use cookies, and it is accomplished with the help of 4 components. Out of the 4 components, 2 are header lines which are used as part of the HTTP protocol. The set cookie header line which is there in the HTTP response message, and a cookie header line which is used in the HTTP request message. Then there is a cookie file which will be kept on the user's host, which is managed by the user's browser, and at the backend database on the website there will be this identification of this cookie file with that particular user. Okay, these are the 4 components that we basically have. So, how are these 4 components actually used? So, it goes like this. So, let us say a user accesses the internet always from the same PC. Okay. So, when he or she visits a specific website for the first time, when that initial HTTP request arrives at the site, what that site will do is it will create a unique ID for this user and create an entry in its backend database, and it will send that information, this cookie information, as part of the set cookie header line in the HTTP response message that it sends. Once that is done, this information will be stored in the user's browser as part of the cookie file. Then subsequently when the user sends a request, there will be a cookie header which is added in the request line, which will have this information which was stored previously as part of this request that is sent. So, it works like this. So, let us say we have a cookie file that is maintained in the browser. It has one entry, some eBay 8734, some entries there. Now, let us say a new request is coming, it is being sent to some website, let us say Amazon.com or something like that. Okay, so, this is the first time this request is coming. So, what the server does is it creates an ID 1678 for this user, and when it sends back the usual HTTP response, in addition to that it sends the set cookie information and says set cookie colon 1678. So, now this information is stored in the cookie file. So, subsequently when you send a message to the same web server, so you say you add this additional header line called cookie 1678. So, when this message reaches the server can now take action based on this cookie. So, cookie specific action it can take, and it can send back an appropriate HTTP response. So, 1 week later, let us say you are accessing the same website. Again what will happen is, if this information is still there in your cookie, provided that you have not deleted your cookies file or something, it will be there in the cookie file. So, this information cookie colon 1678 will be again sent to the server. So, the server now will be able to identify that it is the same user who is making the request now, and accordingly take the cookie specific action and give the appropriate HTTP response. So, this is basically how the cookie mechanism is employed, and it can be used for multiple purposes. So, it can be used for providing things like authorization, it can be used for shopping carts, it can be used for providing recommendations to the user, it can be used for maintaining some kind of user session state for web email and so on. Okay. So, cookies can be used for multiple purposes like that. Only thing that we always have to be careful when you are using cookies is that it always has a privacy issue associated with it, which is that cookies typically can permit sites to learn a lot about you, because once there is some information that is being stored about you, a lot of information can be maintained by a site using these cookies. So, for instance, you may supply name and email and your email address to sites. Okay, so that information could be tracked by means of this cookie. So, similarly, search engines use redirection and cookies to learn a lot more information. Okay. Same thing is true with respect to advertising companies as well. So, advertising companies can obtain information across websites and use this information to target you as the right user for a certain type of advertisements and so on. Okay, so, there are certain privacy issues which are associated normally with cookies, but they have a number of benefits which kind of outweigh the disadvantages that they have. So, this is one important aspect of an additional feature that is provided by the HTTP protocol, which is to support these cookies. Similarly, another very important aspect of the HTTP protocol is something called caching. So, again this is something which is used in order to improve the performance of the web service. So, typically what we want to do is that if there are, for instance, let us say we have a particular institution or organization, there are multiple clients which are accessing a particular server. Okay. Now, many of these requests are for, let us say, for the same server, that is they are getting information from the same server. So, which means that for each of these requests, in the normal situation we will be sending multiple requests for the same information to the server again and again. So, to avoid this, one thing which could be done is that you could have what is called as a proxy server, which is associated somewhere in between, let us say at the end of your institution, and this proxy server can act as an intermediary which receives your request, okay, for the first time, sends the request to the origin server, gets the corresponding response, and once it has got the response, it can cache that information in its memory, and when a subsequent, and pass that response back to the client which requested it. In addition to that, subsequently when some other client requests for the same information, instead of again going back to the origin server, it can return the response from that web server, it is from the cache itself, from the proxy server itself. So, what we gain by this is that the time taken to go from one end to the other end, okay, we are cutting short that time, because you just have to go up to the proxy server and return back from the proxy server. So, this is an advantage that we have of using web caches. So, the advantage obviously, as we can see, is that the overall response time is reduced. So, this proxy server could be located at various places. It could be right at the edge of the institution, or it could be close to the, or it could be anywhere in the internet, and by contacting this proxy, by the use of this proxy server, we are basically improving the service for the different clients. In addition to that, of course, we are also reducing the load on the original server, so thereby improving performance as a whole. Okay, so, this is something that we have, and this is achieved by means of these caches. So, now in order to support this caching, again HTTP protocol provides certain additional features. So, we need to understand what those features are, because without that support from the HTTP protocol, it will become difficult to implement this kind of an idea of using proxy servers for caching the information. Okay. So, let us see what those things are. Okay. So, now a little bit more about what this cache will look like, okay, in terms of the HTTP protocol. So, you can see that if you look at this, the position of the proxy server, it is the recipient of the request at this point, okay, and at this point it is originating the request. So, which means this proxy server kind of acts as both the client as well as the server, right. So, it acts as the server as far as the original client is concerned, and it acts as a client as far as the origin server is concerned. Okay. So, you can see that the cache will act as both the client and the server, which means it will have both the HTTP client processing part and the server processing part, the request processing part and the response processing part. So, typically as I said, the cache will be installed by the internet service provider, say at a university, company, residential ISP and so on. And the advantages that we get of the web cache, as I said already, is that we can reduce the response time, we can reduce the traffic, and it also enables poor content providers to effectively deliver content. So, that is another advantage that we have. So, how is it that HTTP protocol supports this idea of caching? So, we saw that there are a number of conditions that HTTP request can use. When we looked at the HTTP request, we saw that you have conditions like if modified since, if unmodified since and so on. So, these conditions can be used in order to implement what is called as a conditional get. Okay, we have a get, now it becomes a conditional get. This condition is specified as part of an additional header that we have. So, let us say we are first sending this first request. Okay. So, what we are doing here is you are now requesting, if you go back to this proxy picture here, the kind of operation that we want to do is as follows. So, when the client sends the information to the proxy needs to know whether the information it has is up to date or not. Okay. So, if the information is up to date, then it can always send the response to the client, to the first client, second client and so on. So, first time of course it will get it from the original server, second time onwards it has to give back the response provided it has the up to date content. Now, in order to do that, it should find out whether the information in the original server has changed or not. It need not get the complete information, but it just needs to know whether the original content has changed or not. So, what the proxy server can do for that purpose is that it can send a request to the server asking whether this particular file has been modified or not. So, if it is modified, then you are requesting the origin server to send back the entire file. If it has not been modified, it need not be sent back. Okay. So, this is what we are trying to achieve with the help of this conditional get mechanism. So, what we do is when the HTTP request goes to the proxy server, what the proxy server now will do is it will send a HTTP request message to the origin server saying if modified since and specify some date. Now, this date would normally be the date which it stores when the original file has been retrieved from the server. Remember that when a response message comes, the response message will have the date on which that particular file was last modified. So, that information will be stored. So, it will say if modified since that date, then this particular object has to be returned to me. So, let us say the object was not modified. In that case, what is the response of the server? All that the server gives back is, it gives back a response which says 304 not modified, status saying that this file has not been modified. So, the entire file need not be returned, just the response header alone needs to be returned. So, once it is not modified, now the cache can take care of the request from its cached copy. Okay. So, this is what you will have. If the object has been modified, in that case what would happen? The server would actually send back the original file with the status message saying HTTP 1.0 200 OK, 200 OK in the sense that the request is being satisfied. So, it has been modified, therefore, the information has to be sent back. Okay. So, the server based on the server response, now the original file that is now retrieved can be now given to the client. Okay. So, this is basically how the caches work. Okay. So, with the help of these two important phenomena, caching and cookies, the entire efficiency of our web services has been improved tremendously. So, the next protocol that we will look at, we have looked at the HTTP protocol. The next protocol that we will look at is again another very popularly used protocol, which is the one which is used for electronic mail. Now, email is again one of the very popular applications which is used on the internet today, and the protocol associated with that happens to be a very simple protocol. So, in fact, the name itself says that, it says it is a simple mail transfer protocol. So, we will take a look at this simple mail transfer protocol now. So, let us look at again the various components that are there for SMTP protocol to work. So, if you look at this picture, okay, so you can see that we have a mail server, in fact, many mail servers are there, and there are many user agents which are connected to those mail servers. Okay. And between these mail servers, the protocol that is used is the SMTP protocol. So, the three components that we have as part of the electronic mail application is that we have user agents which are connected to mail servers, and mail servers talking to each other by means of the SMTP protocol to exchange messages among them. Okay. So, what the user agent is responsible for is that it is also referred to as the mail reader. So, it is responsible for things like composing a message, editing the message, reading the mail messages and so on. So, different Outlook agents that we use are like your Outlook which is used, or Mozilla's Thunderbird, okay, all these are examples of user agents. And the outgoing and incoming messages which are coming from this user agent are typically stored on the server, and so they access the server and get the information from the server. So, what is it that we expect the servers to do? Okay, the server will consist of messages, message queues and mailboxes. So, mailboxes are where the incoming messages are stored, and message queues are where the outgoing mail messages, the ones which are to be sent, will be stored. Okay. And of course, it will also implement the SMTP protocol so that it can talk to the other mail servers. Again, what is interesting to remember here is when a mail server is sending message to another mail server, it acts as the client, and when it is receiving message from another mail server, it acts as the server. So, it is so you can see that both the client part and the server part will be implemented in the mail servers. Now, the RFC that is used for the electronic mail, the SMTP protocol, is 2821, and SMTP also runs on top of the TCP protocol, the transport layer protocol, and it runs at port number 25. So, port number 25 is the well known port for the SMTP server to run. Now, if you look at how the data transfer actually takes place, you will see that there are three phases of transfer in the case of the SMTP protocol. So, you first have a handshaking or a greeting part, then the actual transfer of messages will take place, and then finally the transaction will close. Okay. So, these are 3 parts in which you can see the SMTP transfer taking place. And as part of the transfer of these messages, and for each of these things, there are a set of commands which are given from the client to the server and a set of responses which come back from the server to the client. And both commands and the responses are given in the form of ASCII text and in terms of phrases. So, your response comes back in the terms of as a status code and a status phrase, and all messages are in 7-bit ASCII. So, everything is directly readable. So, this is a typical scenario that you have whenever a message is sent. So, let us say Alice sends a message to Bob. Okay. So, Alice is connected to her mail server here. Similarly, Bob is connected to another mail server here. So, when Alice sends a message to Bob, okay, so to bob at someschool.edu. So, what Alice will do is, Alice user agent, that is let us say the Outlook that she is connected to, will send a message to this mail server, okay, and the message will be placed in this message queue. Now, what this mail server will do is, it will open a TCP connection with the other SMTP server which is running on someschool.edu at port number 25, and it will now send this SMTP message to the server. Okay. There is an exchange of messages that takes place between this mail server of Alice and the mail server of Bob. Now, once this is done, once the message reaches the mail server here, it is placed in Bob's mailbox, which can now then be accessed by the user agent of Bob to read that message. So, these are the 6 steps that we have when a message is sent from A to B. Okay. So, the interaction that takes place in terms of the protocol will go like this. Okay. The first thing that will happen between the server and the client. So, the moment the mail server establishes a TCP connection with this mail server at port number 25, this server now responds with a particular message, okay, with a status saying 220. So, let us say chennai.edu is talking to mumbai.org, just giving 2 names there. Okay. So, 220 chennai.edu will be the server's response, first message that is given by the server. Now, client which wants to talk to the server will start off with a hello message. So, it says hello mumbai.org. So, now what the server says is, okay, it says hello, returns a status message of 250 followed by hello mumbai.org, pleased to meet you, some phrase. Okay. Now, the client can now send a message. So, it says mail from say alice at mumbai.org, okay, and the server again responds to that saying that it has received this correctly, saying alice at mumbai.org, sender okay. Now, 250 is the status code. Now, this 250 indicates that everything is fine. Okay, okay is the meaning of this status code 250. So, then it says who the mail has to be sent, right, received to, and you say bob at chennai.edu. So, again it responds with saying 250 recipient okay. Then the data can follow. Since you say have data and that is followed by, but the moment you say data, it says yes, you can send the data, and the data is to be ended with a dot on a line by itself, okay, so which is what we have written here, end with a dot on a line by itself. So, the client now can send multiple lines of text which forms the body of the message, and when everything is over, it puts one single dot on a single line which indicates the end of that data part. Once that is done, then the server has received the entire message. So, it sends back again a success message accepted for delivery, then the client can quit the TCP connection, and your server responds to the 221 saying that it is also closing the connection. So, this is typically the SMTP interaction that takes place. So, these are the messages, and this is the format in which the messages are sent. You can see that it is very similar to the way we normally send a message. So, it is very intuitive to understand exactly how the SMTP protocol works. Only thing is there are certain key phrases which are used, which have to be used in the correct format. So, if you look at how these different messages are sent, SMTP we will see uses persistent connections, which means that once a connection has been established, all these messages are sent along that same connection, okay, and everything is in 7-bit ASCII. So, the entire message, that is including the header and the body, it is all readable, and it will use this. How does the server indicate that you have come to the end of the message? It is a single dot on a single line, right. So, which means you will have a carriage return line feed which indicates end of the previous line, dot at the middle, and again a carriage return line feed at the end of this line, which is used as the indication of the end of that message. Okay. So, this is how the SMTP server identifies the end of the message. Okay. When you compare this with the HTTP protocol that we have looked at previously, now you can say that HTTP is a pull protocol in the sense that the client pulls information from a HTTP server, whereas in this case the server is pushing content to the other side. Okay. So, it is the SMTP protocol, you are pushing the email from one machine to another machine. So, it is a pull versus push kind of a scenario. Both have similar ASCII based command and response interaction and status codes. In that sense, both are very similar. Okay. In HTTP, each object is encapsulated in its own response message, whereas in SMTP, multiple objects can be sent as part of a multi-part message as well. Okay. So, these are certain comparisons that you can look at with respect to HTTP. Now, the different commands that we just looked at, right. So, the important commands to note are, you have this hello command, you have a mail from command which is used to indicate the sender, receive to command to indicate the receiver, data and quit. Okay. These are the 4-5 main commands that we look at. Okay. Now, the question that can normally come up is, let us say that we said that sending a dot by itself will end the data, but suppose in the email itself you had a single dot lying on a single line all by itself. It is actually part of the data. So, we do not want it to be treated as if it is the end of the data, right. So, what do you do in that case? So, what you do is you send a line which contains 2 dots, right. That is, you in the sense, this is what will be done by your SMTP protocol to send a one with 2 dots. So, what happens in this case is that the receiving mail transfer agent, which is your server on the other side or the receiver on the other side, will remove 1 from the message, and so will not treat it as if it is the end of the data. Okay. So, that is something which is done. So, these are some more SMTP commands which are also supported in other and later versions of SMTP as well. So, you have things like verify, which is used to confirm that a name is a valid recipient, that is, you are sending a receiver's name, you want to check that the name is valid. Okay. So, this is used to verify. EXPN is expand, which is used when you are sending group email addresses. So, you can use it for instance to you send a group email address, and this is used to identify all the members of that group. So, turn is used to switch roles, that is, the sender becomes the receiver, the receiver becomes the sender, because on a single connection you can have both way mail transfer taking place. So, the client and the server can switch roles. So, that is turn. Then you have something called send or mail. This option is used to either display a message on the terminal or send a mail to the user. That is, let us say for instance, if the recipient is currently logged in to that server, so you could just display a message on the terminal, but if he is not logged in, you can send mail. Okay, this is called a send or mail. You also have a send and mail option where you will display a message, in addition to it you will also send a mail. Okay, this is another option that is available. Then there is also something called no op, which does nothing, actually no operation, just makes the receiver to send back a positive reply code. So, that is all it does. Then of course, you have reset, which is used to abort a current transaction. Okay. Now, an SMTP server may not implement some of the commands, because some of these are optional commands, so it may not implement some of the commands. If it does not implement those commands, then what it would normally respond with is a 502 response, which says that command not implemented. Okay. For instance, if SOML was not implemented, it would give back a response saying command not implemented. Okay. So, this is how the different SMTP commands are available, and they can be used for various purposes. Okay. Again, you could try SMTP interaction for yourself. That is, just as you can do HTTP, you can telnet into a HTTP server and send HTTP messages. Similarly, you can telnet into a SMTP server and send your SMTP messages and talk to the SMTP server, which is you can be the client and talk to the SMTP server running on the other side. Okay. So, what do you do for that? You just have to follow the same steps, that is, you telnet into whichever server you want and specify the port as 25. So, once you have done this, what you will see is you will see a 220 reply which comes from the server. So, that is whatever responses we just saw here, right, you see this 220 and you saw this response coming from there, right. So, this is the response that you will see from the server. Once you get this response, you can follow exactly these steps. You can specify one hello, specify your name, you will get back a response of 250 from that server. Then you specify mail from and specify your mail address, you will get a response of 250. Then you can say receipt to and send the mail ID of the person that you want to mail to. So, if that recipient is fine, you will get back a response of 250, and then you can send the data and end with a dot, and then you can send a quit to close the message. So, you can do all of this on your own and see how the SMTP server responds to these various commands. Okay. So, once you do that, your understanding of SMTP, the basic SMTP protocol will become very clear. So, this is just an example of how that will look, another example of the same SMTP session. So, you can see that you may find more details depending on the kind of servers that you are talking with, but you will see that the messages that you get and the status codes you get are all very self explanatory. Okay, so you can see this telnet startrek.com 25. So 220 Star Trek, hello 250, mail from 250, receipt to 250, all fine, data, you are sending the message and then you are closing the connection. So this is one example of this. You can also try relaying mail to someone on another system. So because you can also use the SMTP protocol to relay mails to other systems. So you could send something like this. For instance, you can say mail from you have specified your mail ID which is accepted by the other side. Now you say receipt to jim@yahoo.com, which means this has to be relayed to some other web server. So in which case either it may be supported, in which case you may get back a proper response, or you can get back a 550 kind of a message which says relaying denied to this particular person. So relaying again may be supported or may not be supported, and based on that you would get this kind of a response. You can also send message to several people. So what would you do in that case? You will have your mail from, right, and then you can do receipt to, you specify one name, again you get back a 250 response for that, again send receipt to, send another name. So you can send as many names as you want, so and keep sending them as receipt to commands, and you will get back your 250 responses for that, and then when you send your data, the data will be sent to all these recipients. Okay. So this is basically what we have as part of the SMTP exchange. Okay. Now the message, the body that is actually sent will that is the mail message format if you look at. So this will again have a header and a body, and this is what we actually see whenever we get our mail, right. You have a to, you have your from, you have your subject. Okay. Now remember that this to, from are all very different from the SMTP commands. This is part of your mail message as such, and this will be followed by the body which consists of the actual message, which consists of ASCII characters again. Okay. And so this will be the format of your mail message. Now this is something that all of you would have seen. Whenever you look at a mail message, there will be a from, there will be a return path, there will be some date, from, subject, to, message ID, content length, status, and there will be a blank line which kind of separates this header from the actual message that is being sent. Okay. So this is typically what you will see as a message format. Okay. So it is this message format that will be sent as part of the data part of our SMTP protocol. So this is basically how this will work. So these are some more such message headers. You will see that there may be additional things which are inserted by some of the intermediate servers. If you have the message not going just directly from one server to another server, but if it is going through multiple relays or multiple relaying agents or gateways, then you will find there are additional headers which may be added as part of the mail message that is being sent. Okay. Otherwise, you will not see these kind of messages. In addition to that, you will also find something like MIME version, content type, boundary and so on. So these are things which are used when we are sending different types of attachments and different types of data along with our as part of our mail exchange. Now how that is done and how these are supported by with the help of SMTP, or what are the features that are added in SMTP to support that, is something that we need to understand also in detail. We will look at that in the next lecture. So to summarize, so what we have looked at are two parts of two protocols. One is the HTTP protocol, where we looked at how cookies and caching are supported in HTTP protocol. Then we have looked at the primary protocol used for email, which is the simple mail transfer protocol. So we looked at message formats and how the messages are exchanged in the SMTP protocol. Other details of how attachments are exchanged using SMTP protocol and other things are for a next part of the lecture. Thank you.